Everybody, welcome to another lesson in Science 10 Chemistry here. Today we're going to talk about the properties of molecular compounds. So, a couple things about molecular compounds. So molecular compounds are made up of molecules, and we've talked about molecular compounds before and identifying them and how they're kind of organized in structure. But today we're going to get into more of the properties of them, what makes them specifically different from ionic compounds. Now, molecules are groups of non-metallic atoms held together by covalent bonds. So we've talked about this already. And each molecule of a compound always has the same number and proportion of atoms in it. So unlike an ionic compound where you could have sodium chloride, for example, you can have a giant crystallized structure of sodium chloride, or you can have just a little bit of sodium chloride, but it's still an ionic compound as long as you have that 1-to-1 ratio. Now, this is different with molecular compounds. Again, each molecule of a compound always has the same number and proportion of atoms in it. So all molecules will always have one hydrogen and two oxygen atoms, and we're talking about the water molecule there. You're not going to have two hydrogen and four oxygen. That's not a water molecule anymore. Now, the attraction between individual atoms in a molecule is very strong, whereas the attraction between neighboring molecules is very weak. And because of this, the melting point of molecular compounds tends to be much lower than the melting point of ionic compounds. So again, comparing that to table salt of an ionic compound takes a whole lot of heat to melt salt. Whereas with a molecular compound, you don't need near as much. Now in molecules, only a small amount of energy is required for molecules to slide past one another. So note that the molecule itself does not break up during the melting, and for this reason, melting is not considered a chemical change. Now, if you flip to table A2 1.5 in your textbook, and that's on page 59, you can see some of the 5 common molecular compounds and their properties. And so just to give you an example of specifics of what we're talking about here. Now, molecular substances can form crystals such as snowflakes, and unlike crystals of ionic compounds, crystals of molecular compounds crumble easily. So example, sucrose, which is sugar, it turns into a powder when grinded. Whereas again, we go back to the example of an ionic compound, sodium chloride, so NaCl, you can grind it down, it's still going to maintain its crystal structure. Now, the relatively weak attraction between the molecules means that the crystals do not hold their shape. Now, ionic and molecular compounds are also different in electrical conductivity. All molecules are electrically neutral, so both as solids and in solution, meaning that they do not conduct electricity really in either state. So whereas when we talked about ionic compounds, we have something that does conduct electricity very easily. Now, one of the most special properties of a molecular compound, and we're going to talk about water here, is the polarity in water. So that means it has a positive and negative end. Now, water has this property because of its bent shape and because of the unequal sharing of electrons in the bond holding the hydrogen and oxygen together. And this makes the oxygen end of the water slightly negative and the hydrogen end slightly positive. This makes water molecules attract to each other and makes it easier for water to form liquid than if it were not polar. So it is very important that water is polar. If it were not polar, all the oceans would boil away even during the coldest winter. That's because they don't have that affinity to attract to one another and nothing really holding it together. Now, life would be very different as much of the thermal energy at the Earth's surface is held by water in oceans, lakes, and rivers. So they really determine the energy patterns that we have and why we have, the further you're away from water, the more crazier weather patterns can be. That's why, an example, in kind of central Canada here right now, we just experienced a giant snowstorm, but you can go from those extremes of being very warm to very cold. Whereas if you're more on the coast, you're more near the equator, where you have those large bodies of water, you don't get quite the same extremes. Now, in the summer, the oceans act as a heat sink, absorbing heat from the sun and in the air. In the winter, they are a heat source, radiating stored heat. Both of these effects keep the Earth's surface temperatures from swinging too high or too low. And living systems depend on this stability that water has. Now, as liquid, water turns the ice and the molecules spread out. So, if you were to take a water bottle, fill it full of water and put it in a freezer, that water bottle expands. And to the point, if you have it right full to the very top, it's probably going to crack your water bottle. That's why if you're freezing water, it's not wise to fill it right up. Now they line up in a 3D array that contains 6-sided rings. So there's a picture for you of how water molecules look when they line up, and you can see the oxygen ends and the hydrogen ends clinging together because of their polarity from one another. Now from this 3D array comes a reason that every snowflake has 6 sides or 6 points. The ordering of water molecules in ice also means that there are fewer molecules in a liter of ice than in a liter of liquid water. So if you were to take a bunch of snow, for example, put it in a pail and boil it or warm it up and let it melt down, you're going to have a lot less there than you started with. Now liquid water is denser than ice, and that is why ice floats. So I got a question for you. What does this mean for fish? So if liquid water is denser than ice, and that is why ice floats, okay, so keyword being denser, what does this mean for fish? And if you kind of really thought about it, think about how they float, how they move through the water, think about the density of their bodies. And this is something we can discuss later, but it all goes back to the density and how the molecular structure of water is being formed. And that's pretty much that's it for our molecular compounds and their properties. I mean, a few differences compared to ionic compounds. There's a short little lesson today, but now you can kind of see the differences and how we can really decipher between the two. So hope you learned a bit today, and thanks a lot.